Number 1 says, consider the equation x squared equals 9. Show that 3, negative 3, the square root of 9, and the negative square root of 9 are each a solution to the equation. So if we're going to show that these are solutions, I'm just going to plug them in and show that they work. So instead of the x, I'm just going to plug in these numbers. So here we have 3 squared, which should equal 9, right? And we know that squared means to multiply something by itself. So it's 3 times 3, and 3 times 3 is 9. So we end up with 9 equals 9. So we know that that works. Then negative 3, I'll do the same thing. So negative 3 squared, does that equal 9? If so, it's a solution. So here we have negative 3 times itself. So negative 3 times negative 3. And negative 3 times negative 3 is positive 9, which shows that both sides of these equations are the same. And so that would be a solution. Then square root of 9 we'll plug in. So square root of 9 squared, does that equal 9? And so this means we're doing the square root of 9 times the square root of 9. And there's probably a couple different ways you could show this. This is just the way that I'm going to do it. So square root 9 times square root 9. So this really means that we're doing square root of 9 squared, right? Because we've got 9 times 9. And that's the square root of 9 squared. And then we know that a squared and a square root are inverses of each other, so they cancel each other. So then we end up getting 9 equals 9 for this one as well. Then for negative square root of 9, so we have negative square root of 9 squared, and let's show that that's 9. So using this same idea, we'd have negative square root 9 times negative square root 9. So we know that a negative times a negative means that we're going to have a positive. So I'm just going to write this here to show that I looked at that. And then we have square root of 9 squared, because we're doing 9 times 9 with that square root. And then we know that a square root and a squared are inverses of each other. So again, those will cancel. And we end up with 9 equals 9. And that shows that that one is a solution as well. So then for part B, we want to show that these two solutions, or these two numbers, are not solutions. So let's show that 9 is not a solution. So when we plug it in, 9 squared, does that equal 9? Well, 9 squared is 9 times 9. And 9 times 9 is 81, which does not equal 9. So that is not a solution. And that shows our work showing that it isn't a solution. And then square root 3 squared, does that equal 9? And so, in this one, maybe I'll just do this idea that the square root cancels the squared here. So that works this way as well. Okay, so it works if your square root is inside the squared. So square root and squared are inverses of each other, so they will cancel each other. And then we end up seeing that we get 3. And 3 does not equal 9, so that is also not a solution. Number 2, solve this equation and explain or show your reasoning. So here we have that some number squared is 16. So what numbers squared would give us 16? So if this number in here was 4, we know that 4 squared is 16. And if this number in here was negative 4, we know that negative 4 squared is 16. So these would produce solutions. So what this means is that whatever is inside of this parenthesis needs to be equal to one of these numbers. So this x minus 1, if that equals 4, then we would have a solution, because then it would be 4 squared equals 16. Or if that x minus 1 equals negative 4, that would also be a solution. So negative 4 squared is also 16. So then we can solve each of these equations. So I'll just add 1 to both sides, and we get x equals 5 as a solution. And then we can add 1 to both sides here, and we get x equals -3 as another solution. So then let's just plug it in just to make sure, just to always check our work. So if we plug in 5 here, we would have 5 minus 1 squared, and that should equal 16. Well, 5 minus 1 is 4, and 4 squared is 4 times 4, which is definitely 16. So that's good. That means that this is in fact a solution. And then let's plug in -3 for x. So we'd have -3 minus 1 squared should equal out to 16 if it's a solution. -3 minus 1 is -4. And then -4 times -4 is in fact positive 16. And so that means that -3 is also a solution. Number 3 shows us one way to solve this equation, and it wants us to explain what is being done in each step. So here's the original equation. So what is different from this equation to this equation is the question. And so we see that this 9 is no longer here. Okay, so this is just 5, and then this becomes 45. So what they did here was multiplied 9 to both sides, because then we would have these 9s cancel out, and then 5 times 9 is 45. So in step 1, they just multiplied both sides by 9. So then again, that canceled out the 9 here to just have 5, and then 9 times 5 was that 45. So then what happens in step 2? So what do they do to go from this equation to this equation? And so now we see that this 5 is gone, and the 45 is now a 9. So that means that they divided 5 to both sides of the equation, because 5 divided by 5 is this 1, y squared, and 45 divided by 5 is 9. So here they divided both sides by 5. Then for the final step, okay, so now it says y squared equals 9, and they go and find y equals 3 and y equals -3. So they just wrote down and found the numbers, the number or numbers. In this case, it's numbers. Okay, so the number or numbers that squared equal 9. So 3 times 3 is 9, and -3 times -3 is 9. So those are the solutions to y squared equals 9. Number 4, Diego and Jada are working together to solve this quadratic equation. Diego solves the equation by dividing each side of the equation by 2 and then adding 2 to each side. So he writes this. So he divided by 2, and then he added 2 to get rid of that -2. So Jada asked Diego why he divides each side by 2, and he says, I want to find a number that equals 100 when multiplied by itself. That number is half of 100. What mistake is Diego making? So when we talk about half equals a number plus the same number. Okay, so this is adding. So half of a number is the number that adds to itself to get to a number. Okay, so 50 plus 50, right? So it's 50 plus 50 that equals 100, not 50 times 50. So then part B says, if you were Jada, what could you say to Diego to help him? Okay, not tell him, but help him realize his mistake. So you could say, something like, does 50 times 50 because he said he knows that they need to multiply by itself. So you could say, does 50 times 50 equal 100? Okay, or you could say, when you plug 52, his solution, into the original equation, do both sides equal, right? Or does it end up equaling 100? And those are two things that help Diego to think about what he said, okay, and think about what he did and see if he can come to the realization of what he did wrong without you telling him. Number 5, as part of a publicity stunt, which is an event designed to draw attention, a TV host drops a watermelon from the top of a building. The height of the watermelon t seconds after it's dropped is given by this function, where h is the height in feet. Okay, so our time is in seconds and our height is in feet. Find h of 4 and explain what this value means. So if we do h of 4, we're just going to plug 4 in for t. So we have 850 minus 16 times 4 squared. And so we would get 850. And then 4 squared is 16. 16 times 16 is 256. So when we do 850 minus 256, we end up with 594. So this is giving us a time of 4 seconds and the height of the watermelon. So this means that the height of the watermelon is 594 feet after 4 seconds. Then part B wants us to find h of 0. And then what does this value tell us? So now we're plugging in 0 for t. So we have 850 minus 16 times 0 squared. And 0 squared is 0, and 0 times 16 is 0. So that means that h of 0 equals 850. So this is 0 seconds, right? This is the time. So this means that this is the initial height, or we could say the height that the watermelon is being dropped from. Then part C says, is the watermelon still in the air after 8 seconds? So we want to plug 8 into the function. So we want to find h of 8 and then see if this is still above ground. So we have 850 minus 16 times 8 squared. So 8 squared is 64. And then 64 times 16 is 1024. So this would mean that it is not in the air anymore because this is going to equal a negative number. Even if I don't calculate what it actually is, it's going to be a negative number because 124 is larger than 850. So this means that it's going to be a negative number, which means that it's below ground. Now, we know that won't happen because presumably there's a hard surface. It's concrete that they're dropping this onto. Now, if they were dropping it into like water or something, it could obviously get below ground. But so we have this watermelon here. They're going to drop it. This is the ground. Okay, after 8 seconds, it's going to be below the ground. Okay, which means it's not going to be in the air anymore. And really, it means it's going to be smashed on the ground into a bunch of pieces. Number 6, a zoo offers unlimited drink refills to visitors who purchase a souvenir cup. The cup and the first fill cost $10. then refills are $2 each. Here's the expression 10 plus 2R that represents the total cost of the cup and the refills. Part A says a family visited the zoo several times over the summer. That summer they paid $30 for the cup and multiple refills. So how many refills did they buy? Well, we have this original cost of the cup, right? So they initially had to pay $10 for the cup. So if we subtract $10 off of here, then we know that they have $20 left for the refills. And then we know that the refills are $2 each. So we can take that 20 and divide it by 2, and that will tell us that we have enough money for 10 refills. Then in part B, it says that a visitor had $18 to spend on drinks at the zoo, and they buy a souvenir cup. So how many refills can they afford? So again, they have to purchase the cup. So we're going to subtract $10 for the cup, and that means that they're going to have $8 left for refills. And then each refill is $2. So we'll take that $8 that they have left over, divide it by 2, and that gives us enough for 4 refills. Another visitor spends $10 on the deal. Did they buy any refills? Explain how you know. Well, we know that the purchase of the cup is $10, right? So they spent $10. They spent $10 on the cup. That means they had $0 for refills. So they had 0 refills. So no, they did not spend any money on refills. Number 7, here are a few pairs of positive numbers whose sum is 15. The pair of numbers that have a sum of 15 and will produce the largest possible product, which means multiply, is not shown. Find this pair of numbers. So if you remember when we've done problems like this before, the closer the numbers are together, okay, the bigger the product is. So 1 and 14 are pretty far apart. As these get closer and closer together, the product is larger. So the closest that they can get together is to be the exact same number. So if we take 15 and we divide it by 2, we get that 7.5 plus 7.5 would be 15. And then when we multiply those, we get 56.25. Number 8, Claire is 5 years older than her sister. So we want to write an equation that defines her sister's age as a function of Claire's age. So we want to tell what her sister is, how old her sister is in terms of Claire. So if Claire is 5 years older than her sister, then her sister is 5 years younger. Okay, meaning her sister is Claire's age minus 5. And then if we want to write it in terms of Claire, then we want to say Claire equals her sister's age plus 5, because Claire's 5 years older. So we would take the smaller or younger number plus 5 to get Claire, who's older, and vice versa for the other. So now it says graph each function and be sure to label the axes. So in this one over here, I'm going to do Claire versus her sister. So we want the input value to be the horizontal axis. So we're going to put her sister's age here. And then we're going to put Claire along the vertical axis. I'm going to write it here. And then I'm going to spin it over there. Okay, so then we want Claire to be here. And so if her sister is 0, then Claire is 5. So if her sister is 0, Claire is 5. If the sister is 1, Claire is 6. 2, Claire would be 7. 3, Claire would be 8. 4, 9. 5, 10, and so on. So you could finish this whole chart here. And it's just going to be a linear function like that with a rise of 1 over 1 because they each age, as one ages a year, the other one ages a year, right? They're not going to age at different amounts. And so there is the graph to that one. Then for the one with the sister's age as a function of Claire, so we'll put Claire on the horizontal this time, and then we'll put the sister on the vertical. So now for this one, when we're graphing this for what makes sense in actual ages, if Claire is 0, then the sister is -5. So that doesn't make sense. So we need to start at age 5 for Claire because that's when the sister is 0 or born. When Claire is 5, the sister is 1, or sorry, 6, the sister is 1. 7, the sister is 2. 8, she's 3. 9, she's 4, and so on. For every year Claire ages, the sister ages a year. So you have that slope of 1/1. And so then there would be the graph of that function. Then it says, describe how the two graphs compare. And you can have multiple different answers for this one. But we know that these, when I said vice versa up here, okay, about the younger versus the older, really inverses of each other, okay? So since these are inverses of each other, what that means is that their inputs and their outputs are just switched. So these variables, okay, whoops, these variables really just switched places, or the sisters switched places, right? Because the sisters are the variables in this case. So the variables just swapped. So our ordered pairs in this orange graph, right, are Claire's age, comma, the sister's age. And then in the other graph, okay, then we have the sister's age, comma, Claire's age for our ordered pairs. So if we looked at an example, whoops, a specific example here of this, we could look at this first point here. Claire is 5, the sister is 0. Well, this is true in this one as well. The sister is 0. She's just our horizontal this time, and Claire is 5. So they just swapped places. Number 9, the graph shows the weight of snow as it melts. The weight decreases exponentially. By what factor does the weight of the snow decrease each hour, and explain how you know? So we can find the growth factor by looking at the new amount over the original amount, or a second value over a first value. I just like to do it as scale factor, similar to what you'll do in geometry. So, and you want to do consecutive points. So this new value here, okay, after 1 hour is at 6. And the one right before it, okay, is the original one. That one's at 15. So we have 6 for the new measurement, 15 for the original measurement. And then you can simplify this fraction. So both of these divide by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. So this would be our growth factor. Or in this case, it's decaying because it's less than 1. Does the graph predict the weight of the snow will reach 0? Explain your reasoning. So the graph actually does not predict that it'll equal 0, because each time we're doing 2/5 of the previous number. And when we do 2/5 of a positive number, right, because these are positive numbers, that's never going to equal 0, because the only way to get 0 when you multiply is for one of the numbers being multiplied to be 0. So it never actually reaches 0. It obviously gets very, 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 very close to 0, but it doesn't actually technically reach 0, okay? So not technically. So your graph does not predict that. Now, will the snow actually equal 0? Will the weight of the snow actually equal 0? Okay, yes, right? All the snow okay, because all the snow is going to melt. Okay, it's just that this model doesn't predict it actually gets there. For all intents and purposes, it equals 0, right? If you continue to do 2/5, it reduces to a number that's so small that the snow is gone. Okay, but mathematically speaking, in the prediction, no. In actuality, yes. You will have 0 snow left.